See, the protocol that is preventing loop if loop occurs is spanning tree protocol. There are many chances that traffic can form a loop in the network. What is loop? Coming back again and again to the same place where you started. Say for example, we have 3 switches like this. Do you see my screen?
Yes, sir.
And let's call this as switch 1, switch 2, switch 3. When a packet comes to a switch, it wants to go somewhere, some destination. When the switch do not know the destination, what will it do? Answer.
It will broadcast.
Very good. It will send it via all the ports except from where it is coming. So it will send it to this port and this port, correct? We can call this as flooding or broadcast. It's okay to say. Other than from where it is coming, it will flood it to all the ports. So in our case, we have 2 other ports. So the flooding goes to switch 2, and switch 2 also don't know what switch 2 will do. This will also flood, yes?
Yes, sir.
It comes down to switch 3. And switch 3 also don't know what it will do, flood. So it comes back to switch 1. Likewise, this packet that was going from switch 1 hits the switch 3, and switch 3 don't know the destination. It will flood, so it comes to switch 2, and switch 2 also don't know, it comes to switch 1. But so you can see that there is a two-way loop. There is a two-way loop. This loop need to be controlled, otherwise what will happen, you know? The entire bandwidth will be occupied by this looping packet. Slowly your network will become slow, and then it will totally stop supporting packets. Your network will, the entire office, the entire layer 2 segment will be stunned, will not be able to push any packets. Now, how do we avoid this? By having this protocol STP, you can avoid it. I'm not saying by enabling this protocol, I'm saying by having this protocol. Why, you know? Before you think about loop, before you find that there is a loop, switch will already find the loop, and switch will already stop the loop. Before the loop occurs, before this type of loop occurs, spanning tree can easily understand that there are chances of loop, and that spanning tree can stop the loop. Automatically it can stop the loop. So this is a protocol that reduces our work. If you don't have spanning tree, what you need to do, you need to find some way to stop the loop, which will be a difficult task for you to do. First of all, the reason for loop, if you see here, number one is the destination to which the packet is going is unknown. That is one reason. What if the incoming packet itself is a layer 2 broadcast packet? Say ARP will send a layer 2 broadcast. So switch will obviously flood it, broadcast it, and loop will occur. So you cannot blame the switches for the loop. There are some services like DHCP, you know about DHCP, they also send a layer 2 broadcast. There are services which depends on the broadcast, which runs on the broadcast. Every office is using ARP. Every computer at all the time it will do ARP. Every office computer will do DHCP broadcast. So you cannot stop broadcast, but you can avoid loop cost because of broadcast. So now let us see the original reason why the loop occurred. The loop occurred because when a broadcast packet goes here, it sends to everyone because it's a broadcast packet. This also sends to everyone. And because you got the link connecting back to switch 1, it was forming loop. In case if you didn't have this link, if you don't have this link, will the loop occur? Tell me, no?
No.
The loop won't occur. Because you got redundant paths to reach the switches. What do I mean by redundant path? Switch 1 can reach switch 3 via this way as well as via this way. This is called redundant path. Whenever you got more than one path to reach the other switches, we call it as redundant path. Even this is also a redundant path. This is also a redundant path. Packet will go like this, come back like this, come back like this, looping. So whenever you got redundant path, there are chances of loop. The job of spanning tree is to block one of the spot so that that link will be a standby link. Standby. So by making a link as a standby, you can avoid looping. That is what spanning tree does. Spanning tree, by blocking one of the link to prevent loop, by blocking a link, it makes the link a standby link. It makes the link a standby link. So if any broadcast packet comes, it goes here, it will not come back because the link is not active. You understand? Did you understand how the loop is prevented? So because of this standby link, any packet that is going like this will not come back because there's a standby link. Link is not active. Do you understand how the loop is prevented?
Yes, sir.
By blocking one of the port, the link becomes standby. Because it is not an active link, flooding cannot happen in that link. So standby will become active. Oh, sorry. I don't understand what is these things. The standby will become, when the standby will become active? If something goes wrong with this link or this switch or this link, if something goes wrong with any of this, the standby will be made active automatically. Do you understand what I'm saying?
Yes, sir.
Now, when this is recovered back, when this path is recovered back, again it will be made standby by blocking. This is automatic. Who takes care of this?
STP.
Spanning tree protocol. Fine. How spanning tree protocol can do this? How spanning tree protocol knows that there are chance of loop in this design? So before you identify a loop, before our packet go and before we identify the loop, before that, switches will know that there is a chance of loop. Just to load. Okay. How is that possible? You know, switches send a hello packet. And you know the name of that hello packet?
Yes, sir.
What is that?
In
What is?
OSPF, sorry, in EIGRP.
No. In switches,
Hello packet.
on every port, switches will send a hello packet. But it is not called as a hello packet. It is called by some other name. Do you know what it is? It is called BPDU.
BPD.
BPDU. What is this BPDU? Stands for Bridge Protocol
Data units.
You know already. Did I
Yes,
already
sir.
teach you this?
No, I know about protocol data units. PDUs.
Very good. PDU is protocol data unit. That is correct. This is bridge protocol data unit. Bridge means what? Switches. Layer 2 protocol data unit. Now this packet will be sent by every switch. So say for example, switch 1 is sending BPDU 2 copies. One via this port, another via this port. So inside the BPDU, even this port number will be mentioned. F0/1 coming from switch 1. Now when this BPDU goes to switch 2 will learn that I'm connected to switch 1 and switch 2 will forward it to switch 3 and switch 3 will also forward it to switch 1 back. Now when switch 1 receives the BPDU sent on F01 but received on where? F02, it understands that there is a possibility of loop. You understood what I said now?
Yes, sir. Yes, sir.
See, if the BPDU that is sent on F01 received on some other interface of the same switch, then switch will know that there are chances, there are possibility of loop. So immediately what it will do, it will start the STP process. On every switch they start the STP. Automatically, you don't need to enable it. The STP protocol gets enabled on all this protocol. No, sir, all the switches. That will make the STP to identify a blocking port. By blocking the port, that link will become standby. That is how the loop is avoided. Now, how many ports do you have in this topology between the switches?
3 ports.
Hello. I'm not asking how many links. I'm not asking how many links. I'm asking how many ports. What happened to you? If you have 3 links, how many ports per link? 2 ports, no?
2 ports. Yes, sir. Total 6.
So now there are 6 ports. Which one to block? STP will block a port to prevent loop. That's what we learned.
Yes, sir.
But now our question is how it knows where to block. How it knows where to block. Can be blocked in anywhere, but it cannot block randomly somewhere. If I need to block here, there should be a reason why I am blocking here. So how STP finds that one particular port to block so that loop can be prevented? Likewise, if we take this topology, will loop occur here?
No.
What no? Why no? Why no? Loop can occur even here also. So STP will block a port.
Yes, yes.
So STP will block, if it is blocking here, then why it is blocking here? Why not here?
Yes, sir.
In this topology, if it is blocking here, why not here or here? Why only here? So there will be a procedure, otherwise STP cannot be a good protocol. There should be a standard procedure to block a port. If you take this topology, even here also, traffic can go this side, come back this side. Go this side, come back this side. Likewise, go this side, come back this side. Go this side, come back this side. So loops are easily possible even in this topology. Just 2 switches with 2 links. So now STP have to block to avoid loop. Things. Now let us see how a blocking port is selected. Among these 3 switches, let's take these 3. Okay, I'll draw another diagram. Three switch 1, switch 2, switch 3. F01, some randomly I have connected. Now every switch will have a default priority 32768. Don't forget. And all the switch will have a unique MAC address. Let's say switch 1's MAC address is this. Switch 2's MAC address is, switch 3's MAC address is, right now To find a blocking port, one of the switch will be elected as a root switch. What switch?
Root switch.
This root switch will not block any port. If a switch is elected as a root switch, the ports of the root switch will not be in a blocking mode. It won't go to a blocking state. So how it is elected? Based on the priority. Listen, spanning tree. Is spanning tree spelling is starting with S or B? Tell me. Spanning, is it S or B? First character.
Yes.
Small, starting with spelling S or B? Small.
Yes.
That is how you have to remember. Spanning tree will always like for small things. Small priority. If any switch have got small priority, you should not have any confusion here, whether small or big. See, in OSPF only it is big router ID, big priority.
Yes, sir.
When it comes to spanning tree, you should not have any confusion. Spanning tree is S. It is beginning with S. So, it is S and S. You should always remember without any confusion. If someone confuses you, you should not get confused. Is OSPF look for bigger priority or small priority? You should be very clear. Okay, if spanning tree is small, opposite is OSPF. In OSPF, big priority. Big
Yeah.
router ID.
Yes, sir.
In
Router ID.
OSPF, big router ID. First, big priority. If priority is a tie, big router ID. Spanning tree, S, small. So the switches are compared. See how the switches knows about the other switch other switch priority through BPDU. I told you BPDs are sent every 2 seconds in the switches. So when switch 1 receives BPDU from switch 2, switch 1 will know the priority of switch 2 and switch 3 and vice versa. So they will compare their priority. If a switch has got lower priority, that switch will become a root switch. Yep. So that switch will become a root switch. The switch with a lower priority. Secondly, if the priority is a tie, it compares the MAC address. Again, small priority. If it is a tie, small MAC address. First is priority. Now tell me which switch has got the lower MAC address in our example here.
How can we find that?
I told you, no, small MAC address. See the MAC address that I have written here, example.
Yeah.
Good. Now, this is going to become a root switch. See, understand. There is a tree. This is the soil. And here is the root of the plant. The stem is growing. Yeah? From stem,
Yes, sir.
the trunk, branches are growing. Have you seen any branch connecting like this?
Oh,
No. Branches should not connect. That is why the name spanning tree. See, it is going to form a tree now. This is a root, and it is going to form a tree like this, and by blocking one of the port, it is disconnecting this connection so that there won't be loop. You understand the name why it is
yes, sir.
spanning tree? Okay. Okay, so if the priority is small, that switch will become a root switch. If the priority is a tie, based on the MAC address, the switch will become a root switch. That switch 1 has become a root switch, and these two ports are now designated to forwarding port. Designated to forwarding. These two designated means what? Appointed as
Yes, sir.
forwarding port. They are appointed as a forwarding port. Now, this switch or this switch needs to block somewhere. This switch will never block because it's a root switch.
Yes, sir.
See, if there is a block in this root, what will happen to the other branches? They will die.
Yes, sir.
Root of the plant cannot block. So, blocking may be here or here or here or here, anywhere else in the branch, not on the root. If it is connected like this, block should be somewhere here. Yes?
Yes, sir.
So, what all the branches will try to have is a connection to the root, correct? All the branches
Yes.
will try to have a connection to the root. Will any branch will say, I will not connect to a root? No. If branches will say, I will not connect to a root, they will die.
Yes, sir.
So these are all branches. Now, they want to connect to a root, and they will use the shortest path. This one is shorter than this one. Agree?
Yes, sir.
For switch 2, this port, if it goes out via this port to reach the root switch, the cost is only 19. But if it goes via this port, it is 19 plus 19, which is
Yes, sir. 38.
38. It is very big number. What is this 19? For fast Ethernet, the speed is 100 meg. That's the standard speed of fast Ethernet. When a speed is 100 meg, STP cost is 19. It is predefined. It is already defined. You don't need to know why 19 and how 19 and all. It is standard. Yeah, it is standard. IPv4 is 32-bit. Will you ask why 32-bit? No, because it is standard.
Yes, sir.
So, if you have a gig Ethernet port, it is 1000 meg speed. For 1000 meg, the STP cost is 4. If it is 10 gig, which is 10,000 meg bandwidth, the speed is, the cost is 2. These are all predefined. You understand? Okay.
Yes, sir.
In case if you have gig Ethernet here, it will be what? 2 plus 2.
2.
This is 19. This is only 2 plus 2, 4. Yeah. So
Yes, sir.
S2 would have said, I will go this way. This is the shortest. Shortest is based on the cost. You understand?
Yes, sir.
STP cost. But in our case, all the links are 19. When all the links are 19, switch 2 says, this is going to be my root port. This is going to be my root port. Root port is a port that cannot block because it is connecting to the root. It is talking to the root. It is talking to the root switch. So it is called as root port. See, the root port name is not given to root switch. Root port name is given to the branch switches.
Yes, sir.
So this is the port that talks to the root switch. That's why it is root port. F02 is the root port of switch 2. Tell me what will be the root port of switch 3? What will be the root port of switch 3?
F01.
Very nice. This is the root port of switch 3. Fine. Root port will not block. It will only forward. Now we understood that these 4 port out of 6 cannot block. So now block may be here or here.
Yeah.
Now spanning tree, I said it likes small, correct?
Yes, sir.
So which one is small? BBB is small or CCC is small? BBB is the small
It's
one.
B.
So this will be designated to forward. Small spanning tree likes, so it keep it as forward, and the other one is big, so it didn't like, it becomes block. You understand?
Yes, sir.
Okay. I'm going to demonstrate this. Let's do it in the packet tracer. If you just connect 3 switches, it will do its work automatically. 1, 2, and 3. I will call this a switch underscore 1, switch underscore 2. Switch underscore 3. I have 3 switches. I'm randomly connecting some wire.
Sir, can we connect with any type of wires?
No. It should be only cross cable, dotted wire. Between same device, similar device, switches are similar, no? Between
Yes,
similar
sir.
device, you need to use only cross cable. See, this is what, when I keep here, you can see down, no? Cross cable, crossover
Yes,
cable. So this is the cable. See, nowadays you don't need to worry about this because any wire you connect, they automatically adjust accordingly. But in olden devices, you need to connect only the cross cable. So better you
Okay.
use the automatic because today it is only automatic. Use this one and click, click, click. All right. Now
Okay. Okay.
I'm going to copy the MAC address of this switch. Listen carefully. On switch 1, show spanning tree. This is the MAC address of the switch. See, don't copy this. Don't copy MAC address under root ID. Copy the MAC address under the bridge ID. This is the MAC address of the current switch, whereas this is the MAC address of the root switch which is elected now. There is some switch which is root. This is not a root switch. You see, this is blocking. Anyway, we are going to understand why this is blocking. For that, I am just taking the MAC address. See the priority. What is the priority?
32768.
It is the default. By default, all the switches will have priority 32768. Okay, I am pasting the MAC address here. Likewise, in this switch also, show spanning tree. I'm copying the MAC address, copy only the MAC address that is under the bridge ID. What is the command? Show spanning tree.
Spanning tree.
Copy the MAC address which is under the bridge ID. Yeah. Now, when you compare these three MAC address, because the priority is tie, all switches will have 32768. You see here. See the priority is 32768 here. Also on this switch, 32768. Every switch will have the same priority. When there is a tie in the priority, it will look for a small MAC address. Tell me which one has got small MAC address. See only the first four numbers of the MAC address.
62.
Very correct. 0007. Yeah. So switch 2, if you go and see, this will say I am the root switch. This switch is the root. In the root, all the ports will be in a designated forwarding mode. Did I say that?
Yes, sir.
And they see the cost by default is 19. Yeah. Okay. Now, if this is the root, for switch 1, which will be the root port? F01. Yeah.
Yes, sir.
For switch 3, what will be the root port?
F01.
Same F01. Now, blocking will be either on switch 1 or switch 2. Which one will block? Spanning tree likes a small. So 006 is small. So this will be designated to forward. You don't like the big one, so it will block here. You understand? Because it's 009. You agree?
Yes, sir.
Now, if you go to switch 1 and see, you can see 02 is blocking. Yeah, 02 is blocking. You understand?
Yes, sir.
Whereas here, this one is root port. Which one is root port? F01 is root port, this one. And F02 is a designated forwarding port. You understand how the spanning tree blocks and prevents loop?
Yes, sir.
Now,
Yes, sir.
if this connection goes down, this link goes down, automatically this will be unblocked. You want to see that? Let me show you. You see, I'm disconnecting this wire. Boom. And you will see this one turn green now. Very soon. It will turn green. Earlier, when I was showing you, it was showing blocking, right? But now,
Yes, sir.
it will not block. It will quickly turn to forwarding. Give some time. See, it is in a listening state now.
Designation.
From blocking, it has gone to listening state. And then, after listening, it will learn LRN. Now LSN. See, it is LRN. Learning means it is now understanding the new topology. Learning the new topology.
Okay.
And soon it will be saying forwarding. It'll take 15 seconds. Okay, you see now forwarding.
Yes, sir.
Now, you see, automatically this has turned green. If I connect the wire back, see what happens. I connected the wire back. Again, this will go to blocking. You see, it is already blocking. Let me show you back. Take you back. See, it was forwarding before, but now blocking. You understand?
Yes, sir.
This is automatic. Did I do any configuration to do this, achieve this? Nothing. Only theory in this topic. You learn how it works, but you don't do any configuration for this. But when you come to CCNP and CCIE, we will also tune these things.
Okay.
We also have another 3 different type of spanning tree. This is industry standard IEEE 802.1d standard. One D standard per VLAN spanning tree protocol. There are many more like IEEE 802.1s, 1W, which is called as rapid spanning tree, and multiple VLAN spanning tree MST, which we'll be learning in our next level. Right.